Okay, in the previous part, when we talk about rational numbers, recurring decimal is part of the rational numbers because recurring decimal can be changed into a fraction. Okay, so the changing into fraction, right, you may not need to know, unless your teacher gone through it. So we will focus on the how do we write a recurring decimal. So to write recurring decimal is we are using dots to represent. So for example, 1/6. If you punch your calculator, 1 divided by 6. Okay, you can don't use the fraction button, you can use the divide button. If you do this right, then you will get something like this. You will realize that your calculator will have a chain of 6. And actually the chain of 6 will stop at the end of the screen due to the limit of your calculator. So if your calculator can only support like 12 numbers, then it will stop there. But in actual fact, if you observe right, the 6 is a repeating number. So that is the feature of a recurring decimal. So that means this number 6 actually can go on. You couldn't see it because you're limited by your calculator screen, but it is a number that can go on. So a way to represent things like this will be a dot. So I will put a dot on the 6 to indicate that 6 is repeating. I don't put a dot on 1 because 1 is not repeating. So the repeating number is 6. So I put a dot. Okay, so let's observe other type of recurring decimal. So if you got 2/11, you can punch divide by 11. You will see something like 0.181818181811. So in fact, what is being repeated here? Okay, so at the back there should be another 8. So the 18 is the one being repeated. So you put 2 dots. So when you put 2 dots on 18, I know that 18 keep repeating 0.18181818. Okay, so that is the function of the dots. Okay, the next one, if you press 17 divide by 27, you will get 0.629 and so on. So the repeating block is actually 629. So do I put 3 dots, right? No. We only put on the first and the last. So I will know that 629 is repeating. So the maximum number of dots is 2 dots. So let's say if I got something like 1457, 1457. So the repeating block is 1457. So this block is the repeating block. You also do the 2 dots on the first and the last. So we will not dot 4, we will not dot 3. So we are limited to 2 dots. Okay, so that is the feature of recurring decimal. It can be converted to fraction. So subsequently, there are some examples that I'll be showing. But like I say, if your teacher never do this with you, you actually don't need to learn. Okay, a way that they like to ask about recurring decimal is something like this. So in part A, right, your job is to find a fraction that is exactly halfway. So you can draw your number line. Still remember your number line, like 0 is here, then like 1, 2, okay. But I want to represent 5/5 and 8/5. So I'm just going to draw it bigger here. So where is my 5/5? 5/9, sorry. So maybe 5/9 is somewhere here, and 8/9 is somewhere here. And I'm interested in the number that in the middle of the two fraction. So anytime you want to find the in-between number, it's actually quite easy. You add up the two fraction and then you divide by 2. You add up the two fraction and you straight away divide by 2. And then you can just punch calculator. It will get you a 13/18. So this is the fraction that is right in the middle of that two fraction. And I'm going to express this in part B. I'm supposed to express that fraction into a recurring decimal. So you punch 13 divided by 18 on your calculator. You will get 0.7222222. So there's a lot of 2. And like I say, you are limited by your calculator screen. But it's quite obvious that 2 is the repeated number. So you put a dot on 2. Okay, so that is one way that they will ask about recurring decimal. Okay, so this is mainly on the idea of recurring. So later on, this can be factored into some arrangement, some questions that needs you to arrange numbers. Okay, so that's example 1 and 2.